Okay, so good afternoon. Let us continue our lesson. So there is no lesson left for the exponent, but I want to go through some problems together, try to improve our skills in calculations. Yes? And then next week we start the fresh topic of algebra. So last time we learned these two formulas, yes? So we learned that if I have nth root of a and I want to multiply it by nth root of b, I can write 1/nth root and I can multiply the expressions under these signs. Of course, whenever you want to work with these roots, you need to be a little bit careful, because if n is even and the number that is below that is negative, that is not actually defined at all. So this is something you need to be careful. So when I write this formula, I implicitly mean that if n is even, I have to respect that a and b should be non-negative. Yes? Even though I haven't explicitly mentioned them here, but you need to always think in that way. So let me just write it. If n is even, then a and b have to be non-negative. So for this formula, because every formula has a limitation, so you need to know the domain of applicability of that formula. So this formula works for this case. And of course, if someone asks you to explain this, you should be able to explain these things, because we have already talked about them. And we have a very similar formula for this. If I have the nth root divided by another nth root, then I can write 1/nth root and a over b. One thing that also we have to be careful is that b shouldn't be 0. Even if n is odd, b still cannot be 0, because the denominator cannot be equal to 0. Okay, I just want to write some examples for you to see. If, for example, someone asks me to calculate this, square root of 3 multiplied by square root of 27. Okay, first of all, are these two numbers defined? When this number on top is not written according to that convention, it is 2, 2 is even, but no problems, because both 3 and 27 are positive, so these two make sense. Okay, when it makes sense, I can use the formula. When, of course, it is very important, let me emphasize by another color here, that these two numbers should be the same number. If they are not the same, then this formula doesn't work. For example, if this is the third root of 3, and I want to multiply it by the second root of 27, I do not have that formula. We can discover a new formula for that situation as well, but let us just, for the time being, do this. So if I see this, so everything is in order, so I put another square root sign, and I multiply the numbers below that. And for example, you just calculate this. 3 times 27 is 81. And if I ask you what is the square root of 81, the answer is 9. So simple calculation. The square root of 3 times the square root of 27. If you ask me, do you know, Babak, the exact value of a square root of 3? I would say no, because there are infinitely many decimal points. But that's the same story here. But fortunately, do I know the value of this product exactly? Yes, it turns out to be exactly equal to 9, even though I do not know the exact value of this, neither that one. Yes? So that's something that can happen. Okay, if I want to give you another example, so let me just write this. The third root of minus 2 multiplied by the third root of 4. First of all, let us check. Is these numbers meaningful? even though I have a negative number here, but that's not a big deal because here 3 is odd. So I do not have any problems. So that's everything is okay. So it means that I can continue and use the formula. So I would write 1/3 with this number 3 on top, and then I multiply -2 by 4. And then what happens? -2 times 4 is -8, and then I have the third root. You can of course answer this question here. This is asking you, can you give me a number so that when I raise it to power 3 it becomes -8? The answer is -2. Yes? -2. So it's -2. But of course, if you want to, I want you to know this, even though that's completely okay. If I have this and I have a negative sign here, so let me emphasize that this is odd, then I can pull the negative sign out if I want to. We already discussed about these things, so let me just remind them. It's very good to have them in mind, because every time if you want to, of course, first of all, you need to think deeply to understand, but after understanding it, you should do it automatically. Okay, so for example, if I want to calculate this, what could I do? If I knew this formula for odd numbers, I pull negative sign out and I write the third root of 8, then I do not need to bother about the negative sign under the third sign. I would say that the third root of 8 is 2, but I have already picked a minus sign outside, so it becomes again -2. So it doesn't matter how you calculate, both of them are completely correct and valid. So what can I write for this? Some of them, of course, you see that again, if you ask me the exact values, I don't know, but I calculated that, and I realized that if I multiply these two numbers, it becomes exactly -2. But sometimes we cannot do that, and then we have to keep this third sign. So don't think that you can always get rid of the third sign. You can always get rid of the third sign if you are not caring about exact values. If just what you care is approximations, of course, you take the calculator, punch it in the calculator, and then immediately you get rid of that third sign. Yes? But if you want to keep the values exact, forget about this, that always I should be able to get rid of the third sign. Most of the time you can't, and you have to keep this the third sign in the problem. So, for example, if I ask you, what do you think about this? If I want you to simplify this for me. So you see that I have a number, and then I want to square it. So what should I do? What is the meaning of this? It means that I can write this and multiply it by itself. This is the meaning, yes? But then I can follow this rule on top. So what happens? It becomes the third root of 5 times 5. But 5 times 5 is 25. So this is one of those examples. You see, I cannot get rid of this third sign. I have to keep it in that way. So if you ask me, write the exact value of this, the exact value is this expression. Nothing more. I cannot go forward. If you want to have a feeling about how big this number is, of course, if you have your calculator available, that would be much better. But you can also have some kind of approximations in your head. So for example, 2 to the power of 3 is 8. Then suddenly 3 to the power of 3 becomes 27. So definitely this number is somewhere between 2 and 3. But if you want to go beyond that, if you need more precision, this is a little bit beyond of the scope of this lesson. So, but you understand this is a number between 2 and 3. But how much exactly, we don't. And we cannot say how much exactly, by the way. If someone asks you, what is the exact value of this? There is one answer. Third root of 25. Yes? That's it. So let me see which parts are good if I want to go through them. There are many hard questions in this case, but they are all beyond the scope of the lesson. So for example, let me just ask you to calculate this. So the fourth root of 80, I want to divide it by the fourth root of 5. So now I want to use the second formula. Can I use the second formula? Yes. Everything is sensible. So what I do, I put the 1/4 root and I divide these two numbers. So 80 divided by 5. But you can do this. What is 80 over 5? Is 16. And then, can I know this expression exactly? Sometimes yes, sometimes no. But here, this is one of those cases that you can answer exactly. What is the answer? 2. Because 2 to the power of 4 is 16. So you continue and write 2. I don't know. For example, what happens if I want to calculate this? The sixth root of 320. Sometimes, of course, this is not very common in high school and higher to use this, but let me sometimes use that. So if I ask you to calculate this, how should you calculate? This is actually another way of writing this. It's not very common in high school and higher mathematics to use this symbol for division, but it sometimes appears. So what happens? I can write the sixth root. I take the first number and I divide it by the second number. But this is simple to do in head, yes? So what's that number? 300 divided by 5 is 60. 20 divided by 5 is 4. I had 60, now I have 4 more, so it is 64. Yes? So the answer is 64. But can you just do it in your head again?
2.
Yes, because again, why the answer is 2? Because 2 is the unique positive number whose sixth power is 64. But if I ask you how many numbers are there whose sixth power is 64, how many numbers are there? Just repetition. Yes? 2. One of them is 2. The other one is negative 2. Yes? But when you see this symbol, by convention, this is always referring to the positive one. Yes? Okay. So what about this one? I have a square root of 12 multiplied by square root of 15 and then divided by square root of 20. So how can I simplify this? As much as we can. So here I have a product, I have a division. Of course, none of them has priority over the other one. But here, if you want to do this division, you need to know the numerator, you need to know the denominator so that you are able to divide them. So it's more or less more natural to do the numerator first. But the numerator is the first rule on there, so it becomes 12 multiplied by 15. And the denominator, we can just for the time being keep it as it is. Yes? Of course, this I want you to do it in this way. You can take your calculator, multiply these things. But I prefer you not to do that. Let us work with this combination. You really don't need to multiply. Of course, multiplication is so simple here. It's 180. But what I am trying to tell, you really don't need to multiply things because you can simplify and then proceed. So if I want to do this, the best way to do it without calculator is not to do this. I just write 12, 15, and I didn't divide it by 20. Yes? Why this is better? Because now I really don't need to do this multiplication. Because, for example, I can start simplify. For example, 15 by 5 is 3 times. 20 by 5 is 4 times. And then this 4 by 4 is again 1 times. This 12 by 4 is 3 times. So what is left is just 3 times 3, which is easier. So this becomes square root of 9, and the answer is 3. Of course, you could also do this, because if I multiply 12 by 15, if I can do it in my head, it becomes 180, and then I have 20, and then I have this. So then this divided by that is again 9, and the answer is again 3. So you get the same answer, but I want you to learn simplification first and then proceed. For numbers, you don't have problems because at most you have your calculator available. But if you don't appreciate this way of doing, then algebra becomes harder for you. Because in algebraic expressions, we do not have numbers so that I can get rid of them by calculating. I am working with letters and expressions. So if you just get used to this way of thinking, let us multiply and then continue, this is not a good idea. Always it is a good idea to simplify if possible and then continue, even though the final answers are technically the same. But for human brain, it's easier to simplify and then continue than carry all the mess with you until the end and simplify at the end. Yes, please.
Does it matter which method we use on the exam?
No. So if you write this one, that would be exactly the same thing here. Yes? Okay. So let me make sure that I am not ignoring something. Okay. But sometimes, so let me see. Okay. One natural question here is that what happens if these two numbers are different? So far, if you look at all these examples that I have mentioned, these numbers are all the same. Okay? So what happens if the numbers are not the same? Let us discuss about that. So, for example, the simplest possible example that I can imagine might be is probably what happens if I have a square root of 2 and I want to multiply it by the third root of 2. Okay? So what can I do in this case? So I cannot use this formula because this formula is only valid if these numbers are the same. But one of the numbers on top here is how much? 2, and the other one is 3. So I cannot use that formula. I need to find a method to do that. Yes?
You can change it to exponent.
Yeah, that's the changing to exponent for. Yes? So it means that if I want to write this, what can I do here?
2 to the power of
2 to the power of 1 half. Why? Because we had this formula. The nth root of a is another symbol that we use instead of a to the power of 1 over n. And this n here is 2, so everyone agrees with that? Yes. And then, what can I write for the next one? 2 to the power of 1/3. But do I have a rule for powers to manipulate this? The answer is yes. So I would write 2, yes, and then 1 over 2 plus 1 over 3. But you shouldn't leave it like this. You can do it in your head, your calculator, or whatever you need. What would be the answer? 5 over 6. Of course, this answer is correct, but when I write it in the surd form, I want you to be able to change it to the surd form. Okay? That is the goal. This is correct, but if I want to write it as a surd form, do you remember what is the meaning? It is 2 to the power of 1 over 6 to the power of 5. That was the definition. But what is this in the surd form? It is the 6th root of 2 to the power of 5. So then it means that I have to write it 5 times and multiply it by itself. So what will be the answer? Now everything is 6 now. So what I can do, I can write 6 and start multiplying 2 by itself 5 times, which is 32. So the answer would be the 6th root of 32. So you see, if I ask you to write this in the surd form, if you stop here, even though this is technically right, but that's not complete because I have asked in the question to write it in the surd form. So then it means that you should be able to write this answer at the end. Yes, is that understandable? So the second root of 2 multiplied by the third root of 2 suddenly becomes the 6th root of 32. Exactly. Okay? So that is my intention. So that you can do. By the way, here, do I really need to write it 5 times? No, because you can just see that 2 is being multiplied by itself 5 times. So instead of doing that, I could have a shortcut. I could say that this is 6 and then it becomes 2 to the power of 5, which is 32. So I can immediately write from here to here. I don't need to write this middle. Okay, so if I don't ask to write the final answer in the surd sign, that's up to you. If you want to do it or if you want to stop there. But if I ask you to write the answer in the surd form, you have to do this calculation and be able to write that at the end. Yes? Yes, please?
Can you convert 2 to the root of 6 to 2 to the power of 1 over 6 and then multiply the fraction by 5?
Yes, you can, but you go back again. That is the wrong logic. The logic is that if I ask you just to calculate this full stop, then that is up to you. If you choose this simpler method up to here, I will give you the full mark. But if I ask you to write this in the surd form, do the multiplication and write the answer in the surd form, if you stop here, it's not complete. It's not wrong. It is correct, but not complete. You have to follow. But then again, if you do this, you will go back to this, which is not the point of the question. So is that clear?
Yeah.
Okay, so sometimes this is important. So if these two are not the same. But now we can immediately invent a rule of thumb for doing this calculation. If you don't want to learn it, that's up to you, but I just want to teach you how to do that. Okay? So what we do is this. Okay, so let me just use this. To understand this a little bit better, let me ask you one question here. So, if I write this, and I ask you to write it in the surd form, so let me choose another number because I want to see this number in front of your eyes. Let me write 3. Then you write the third root of 2. So these are completely the same symbols, yes? But now let me ask you a question. If I write 2 over 6, do you think this number that I have written here and that number that I have there are the same numbers or not? They have to be, otherwise I have problems, yes? Because if I ask you, is 2 the same 2, you would say yes. Is 2 over 6 identical to 1 over 3? No, it's not identical, but 2 over 6 is the same number as 1 over 3. If 2 to power 1 over 3 is different from this, then I have problems, yes? It depends which name I am choosing, but mathematics shouldn't depend on your name. So, if I ask you to write this in the surd form, how do you write it? Yes? First of all, you need to do
The sixth root.
the 6th here and then to power 2.
Yeah.
And then instead of this one, you write
The sixth root of 2 to the power.
to the power of 2. Yes? But then this means that the 6th root of 2 multiplied by the 6th root of 2, then it becomes 2. Is that understandable? So it is also a very good formula. You have it handy. So if someone asks you what is mn, you can write the nth root of a to the power of m. Yes? So if you have this in mind, it is a very good idea. So now compare this answer with this answer. So what is the exponent here, which I haven't written, is 1. What is the exponent here is 2. So it is a very nice connection. I want you to learn that. But that's up to you if you really want to learn and use it. But I prefer you to learn it. So what is happening here? If you want, you can multiply this number and that number by any number that you like. So here I have multiplied 3 by 2, which is 6. I have multiplied 1 by 2, which is 2. Okay? So this is always possible. The reason is that when you multiply the numerator and the denominator, you will not change this number. And when you do not change this number, you will not change the result. Okay? So it means that, I will come to you. For example, if I give you the third root of 2 to the power of 5, I can multiply this by 2, write 6. I have to multiply this by 2 and write 10. But if I want to, I can multiply this by 3, write it 9, and then I have to multiply 5 by 3 and write it 15. I can do whatever I like to. All these numbers are exactly the same. So for example, I can write this, let me multiply this by 10, it becomes the 30th root, but then I have to write 2 to the power of 50. So I want you to learn this trick. So if you have a surd with some power here and some number there, if you want to, you can multiply both of, you can rescale them, but any number that you like. This is in this direction. The opposite is also true. If you have a number here and a number here, if you want, you can simplify those numbers. Yes, I divide this by 10, it becomes 3. I divide this by 10, it becomes 5. For example, from here to here, I divide this number by 5, I get 6. I have to divide this number by 5, I get 10. Now your questions, yes? Do you have questions?
Could I write for 2 to the power of 2 over 6? Could I write that equals to 2 to the power of 1 over 3?
Yes, that is the reason actually. If you remember,
Yes,
I started from here.
Yes, so I wouldn't have to write.
No, you wouldn't have to write, but you need to know.
Yes.
So let me just explain myself. So you see, 1 over 3 is a number. 2 over 6, written differently, I am using number 1 and 3 to write this fraction. Here I am using number 2 and 6 to write this fraction. But this number and that number are equal. So exactly the same scenario. If your knowledge expands, you need to know that all these numbers are the same immediately. So for example, if I ask you, what is the connection between these two numbers? Because you have worked with these numbers so long now in primary school. So immediately you realize that these two numbers are the same. I want you to improve your skill to detect that these are also the same immediately. So how should I know that this one and this one are the same? Because I can see that 5 over 3 is the same as 10 over 6. Why this one is equal to this one? Because 5 over 3 is equal to 50 over 30. Yes? What's your question, Sergey? Is it solved now? Okay. So this is very, very important. So now let me tell you how this will help you to do it a little bit more quickly. Yes?
Almost, not exactly, but almost like when you expand algebra.
Yes?
Not fractions.
Yes? That's exactly the same scenario, yes? Actually, the reason that these are equal is because 5 over 3 and 10 over 6 and 15 over 9 and 50 over 30 are all the same fractions. Because they are all the same fractions, so these two numbers should be exactly the same. So let me tell you how can I use this idea to do it a little bit more quickly. Okay? This I want you to teach and learn. Of course, I told you that I really want you to learn these things. If you don't want to, you can just stick to this one and forget about that. Okay? But if I want to do this, first of all, do you remember if I want to add 1 over 2 and 1 over 3, I take something like common denominator, which is 6. So I want to do the same thing. This number which is not written, let me momentarily write it here. Between 2 and 3, what is the common denominator? 6. So what I do, I will rewrite them with 6. Yes? And I tell myself 2 changes to 6 by multiplying it by 3. I take this exponent, which is not written, it means 1, and I multiply it by 3. And then let me repeat it again. 3 has changed to 6, how? By being multiplied by 2. What is the exponent here, which is not written? definitely 1, I multiply the exponent by 2. Yes? And now I have the situation that these are the same. Whenever they are the same, I do not have any problems for multiplying them. But how should I multiply them? I put this, and I just multiply this by that. 2 to the power of 3 times 2 to the power of 2 is 2 to the power of 5, which is 32. And that is the answer we got there, after all these calculations. So this is up to you if you want to learn this method or not, but I would say this is extremely important. Okay? So you need to feel comfortable with working with surds, exactly more or less like the way that somehow you are also comfortable with working fractions now. Okay? Is that understandable? Okay, so let me try to do this together. I don't know, I want to follow this method that I just talked about. I think you can master that, so don't worry, okay? In the worst case scenario, you just do this thing, which is always the case, and you can do that, okay? So here what I do is this. So let me give you another example. For example, let me write here, I write the 6th root of 5 to the power of yes, let us keep it like that, and multiplied by the, so let me make it 9th root of 3. For example, assume that I want to multiply these two numbers. Yes? So the simple rule doesn't apply here because one of them is 6, the other one is 9. So you need to learn, you need either to do it in the exam like this. Now I am asking you to write it as a surd sign. So it means that even if you do the simple way, you have to know how to go back. Okay? But if you want to use my method that I mentioned here, so what is the best way to do it? Between 6 and 9, you need to find, yes, the common denominator. Something similar. Of course, these are not denominators, but technically, by the way, they are, yes, because this number appears in the denominator, yes? So what is the common denominator between 9 and 6, yes?
18.
18. So don't go higher. You can multiply them, becomes 54. It works, but it is much bigger than 18. So the best choice is 18. So the least common multiple. So this is, as you said, 80. So it means that you take this and rewrite this by 18 instead. Okay? And then what happens? You need to concentrate on the powers here. So, by the way, do you mind if you don't mind, let me make it let me make the power here too. Okay? So here I would say to myself, 6 has been multiplied by 3 to get 18. So this power should also be multiplied by 3, which becomes 5 to the 3. And I repeat the process. Again, I ask the same question. 9 has been multiplied by 2 to get 18. I will take the exponent and multiply it by 2. It becomes 3 to the power of 4. And then what can you do? You can write 118 on top and multiply these two numbers. So it becomes 5 to the power of 3 multiplied by 3 to the power of 4. If that number is so big, then you can use your calculator. So 5 to the power of 3, even probably I need your help if you have any calculator available. So this one is 125. This one is 81. You multiply them. So what's the answer? Do you have any calculator available? Or should I use my phone?
10,125.
10,125.
125.
And that is the final answer. In the third sign, yes? Is that understandable? Yes or no?
Yes.
But if you do not want to do this, you have to write it in this way. You have to write 5 to the power of 1 over 6 multiplied by 3 to the power of 2
Over 9.
over 9. Yes? By the way, here you don't have any way to do it except doing it in that way. Is that understandable? Because here, both these numbers are different, so I cannot use that rule. In this rule, these two were the same, so I could combine them. But here, if someone asks you to write this something in front as one surd, that is the only way that you can do it, by the way. So might be if I want to give you an exam, I shouldn't give you this problem because this is beyond a little bit of the scope of the book, yes? In the book, you can manage this without knowing this rule because you translate it into the language of exponents and then you have a rule that if the bases are the same, I can write the bases and add the exponents. But if I want to use the same rule here, it doesn't work, yes? Because one of them is with base 5 and the other one is with base 3, so I cannot do anything. So this is a little bit higher level, but I think that you can understand it. It is not that hard. Yes? Any questions? Yes?
For the second part you wrote with the fractions, down there.
Okay, yes?
Yeah. Couldn't you still do it if you made the exponents the same? Like 1 over 6, you multiplied that by 3, and then you made both the denominators 18, and then you multiplied 5 and 3.
Okay, can you continue? So you are saying that we can continue something with this. Let me tell you. So tell me.
Yeah, so 1 over 6 times 3, that's 3 over 18. Could we making the denominators the same?
Yes, we can. So we can write 5 in the denominator. It becomes 18, and then this becomes 3. Yes, and then multiplied by 3, and then what happens? I have 4 over 18.
Yeah.
Yes.
And then
Okay.
could you multiply 5 and 3 and have the same? No.
No. This is a very good idea, but you cannot multiply them because the bases are not the same. Yes. But you can do something. What is that something? That something is to write it in this way. And then write this one in this way. Instead of making the bases the same, I made the exponents the same. So then what can I do? I can write it as 1 over 18 here, and then I can write 5 to the power of 3 times 3 to the power of 4. And that is exactly the number that I got here. So this, if you want to do it using the method in the book, this might be a higher level question. But in principle, thank you, it is possible. Yes?
I go to the bathroom.
Yes? Okay. So is that understandable? So this is the if you don't want to use this method that I talked about today for you, this is the only way that you can solve it. And of course, you need to take your calculator and calculate this, which becomes that number again. But then I have 1 over 18 on top, and if I ask you to write it in the surd form, you bring it back into this form. Yeah. So that is the way that you have to do it if you do not want to learn this new way of doing it. Yes, that's up to you which one you prefer. But that is a systematic method. It always works. You find the least common multiple between these two numbers, and then you multiply the exponents by the corresponding factors, and in that case you will get two surds with the same number on top, and then you can immediately use the formula. Yes? So the question is solved. If I multiply two surds with the same number on top, it's easy. If the numbers are different, I can use the least common multiple between those two and then make them equal and then multiply. Is that right? Yes? Okay. Let us see, for example, I don't know. For example, let us do these questions. I want to give you time a little bit to give me the answer. First you, and then if you cannot, we can solve it together. So, another thing is, for example, can you calculate this one for me? It's very, very simple, okay? So square root of 2 multiplied by the 4th root of 8. I want you to learn this trick. Is it hard or not? This trick. So let us use that one. Okay, can you do it for me and read your answer, your final answer, okay? I will pause the video, give you 2 minutes doing this. So forget about these are a little bit more technical, but this should be really, really simple for you. So I want to multiply them. First of all, what I check are these numbers. They are not the same. If they are not the same, I cannot immediately use the formula unless I make them the same. This number is not written here, it's 2. This number is 4. So what is the least common multiple between 2 and 4? 4 itself. Yes? So whenever you understand that, you write surds here and put 4 on top and 4 on top. Okay? For this one, I haven't changed anything at all, so I have to keep 8 as it is. But for this one, this was 2. Instead of 2, I have written 4 by multiplying it by 2. So the exponent which is not written, it is 1. I have to multiply that exponent by 2. So it was 2. Now it becomes 2 to the power of 2. Yes? And then it doesn't matter how do you want to continue. For example, I can just, instead of 2 to the power of 2, I can write its answer. And I have the 4th root. And the next one, the 4th root of 32. 8. And then I multiply it. Now the roots are the same. And I multiply 4 by 8. It is 32. So this is the multiplication of these surds and written them as a single surd. How many of you got this answer right? How many? Okay, so it's good. So this means that you understood the topic, but might be the questions are sometimes harder. So you need to be more careful about being able to solve them. So, for example, here, I want to multiply them, and I see that these two are not the same. So what I have to do, I have to make them the same. Between 3 and 6, what is the good choice? 6, because 6 is divisible by both of them. So it means that I will write 2 surds, and I put 6 here and there. I do not change this at all, because it is already 6, so I just copy and paste. Here I have to be careful. What was the exponent? It was 1, which was not written. 3 has been multiplied by 2, so I have to multiply this exponent. Be careful, do not multiply the number by 2. You have to multiply the exponent by 2. Okay? And now, of course, don't be in a hurry. Might be the first impression is that take the calculator, multiply 16 by 16, and then it becomes 256. Then you have to multiply it by another 16. So why we want to do this? Let us be patient. I just write a surd with the same number on top. Then I have 16 to power 2 multiplied by 16. The reason is that you know this. There is another rule for this. What is that? It's 6, and then it becomes 16 to power how much? 3. You might say that, okay, what's the problem? Again, I have to calculate 16 to power 3, but the answer is no, because there's a shortcut. Why shouldn't I calculate 16 to power 3? Yes?
Because you can simplify.
We can simplify this 3 by that 6. Because I told you that you can multiply if you want, you can simplify if you want. But if I simplify by 3, what is left here is 16. Yes or no?
Yes.
What is left here
2.
is 2, which we don't write. But suddenly what happens? Square root of 16 is 4. So the answer is 4. Of course, if you calculate, that is also possible. But then you need to calculate, I don't know how much is that, 256 multiplied by 60, and then you need to take the square root, which is hard. Then you have to use calculator. But in the way that I did it, we really didn't need any calculator. So this is a more efficient way of doing the same thing. So be careful to learn these simplification skills. That would be very, very important. And then mathematics becomes easier for you. Any questions here? Okay, let us go to the other one. Actually, this could be a mess. I don't know. This was in the book, so I'm just copy and pasting that. So let us see how we can solve this problem, and that would be the last problem we want to solve today. I don't know how do you want to continue, but the first thing is that I see 3, 2, 4, and 12. What is a good choice for that number that I'm looking for? Yes? 12 itself, thank you. So what I do, I will write a 12 here for this. I will write a 12 here for this. I will write a 12 here for this. Oh, sorry. And I will write a 12 for this. But this I don't need to be worried about because this is already 12. I wrote 12, so I just don't change anything at all. Let us go back. 3 has changed to 12. So what should I do? I need to multiply this power, which is 1 by 4. So it becomes 25 to the power of 4. And then here, this number which was not written was 2. It has changed to 12. So it has been multiplied by 6. Can you tell me what should I write below? What should I write here?
125 to 6.
To the power of 6, thank you. And 4 has changed to 12 by multiplying it by 3. So what should I write here?
3.
3. Of course, this is really horrible calculation. If you really want to, even with calculator, if you want to raise it to power 4, power 6, multiply them, even with a calculator is a little bit of mess. But you can do much better. I hope that every one of you find a connection between 25 and 125. They have some connection, power connection to a very famous number. So 5. So 25 is what? 5 to the power of 2. So another way of writing this is to write 5 to the power of, can you tell me? 2 and then 4. So 25 to the power of 4 is 5 to the power of 2 to the power of 4, which is 5 to the power of 8. So I can write 5 to the power of 8 here. Then, do you know what is 125 in powers of 5? 5 to the power of 3. But I have another power here, so in total what can I write? What should I write as a power? I have a power of 3 and then again a power of 6. Yes? No? No. 125 to the power of 6. You told me that 125 is 5 to the power of 3. And then I have a 6 on top. What is the rule? You need to multiply. So it becomes 5 to the power of 18. And then, can you tell me what is happening next? 5 to the power of 3. Another 3 on top. Multiply, it becomes 9. And then I have this. Yes or no? Now it becomes simple. Because I can write as 1/3 with 12 there. I have 5 to the power of 8 multiplied by 5 to the power of 18 multiplied by 5 to the power of 9 multiplied by 5. But this is not hard, at least, to write something. I would write the 12th root. What can I write for this long list? I just write 1, 5, but I have the rule. The bases are the same, so I start adding the exponents. Yes? Is it? 8 and this is 17, 35 and one more. 36. Yes? Yes or no? But I can immediately continue. Do not stop here. Because what happens, this was designed by the person who designed the question, so that this number and that number now can be simplified. Yes? So, by the way, when I simplified by which number? By 12. Yes? So what will be left if I simplify by 12? I haven't talked about that before. So it becomes the first root. I divide by 12, it becomes 1. I divide this by 12, it becomes 5 to the power of 3. But we never talked about the first root because it was so trivial. Yes? What is the first root of 5?
5.
It's 5. What is the first root of any number? That number itself. Yes? So this is the fifth root of this one. So what is the answer? The answer is 5 to the power of 3, which is 125. So without any calculators, we were able to calculate this. If you ask me these numbers, I really don't know anything about these numbers, but the point is that if I multiply them, the answer is not approximately 125, the answer is exactly 125. Okay? So you see, these kinds of calculations you need to get ready for if you want to be in technique program. Okay? And of course, you need to find it a little bit of fun. Otherwise, this would be disturbing all the time. Why I should solve hard problems if the exam would be easier? Okay? So that's up to you. Have a nice weekend. Thank you.
Thank you.
Oh my god, I need to train on this.